All right, in this video, I'm going to talk about the basics of friction. So let's go ahead and get started. So we know from previous sections in Newton's first law, Newton's second law, we talked about the fact that friction opposes motion. It works against motion. It goes in the opposite direction. So if this purple box is moving to the right, the force of friction operates to the left. Friction works against all motion. Friction is also a contact force. We've talked about that as well. It happens when two surfaces rub against each other, and they have to be in contact for friction to work. Air resistance, we've also mentioned. Air resistance is a form of friction, and that qualifies as a contact force because the air molecules have to be in contact with this person's body as they fall in order to resist their fall. That leads us to this next point, which is that friction is a force that we can never get rid of. As long as we're on this planet, we can't ever get rid of friction. And that's actually what led Aristotle, more than likely, to conclude that forces are required to make things move. You and I now know that that's not true, but it's easy to think that because friction always brings things to rest, and you always have to oppose friction. You have to fight friction to get things to move. But forces aren't required for motion. We can get rid of friction if we get outside of the Earth's atmosphere. All the satellites in space are orbiting because there's no friction there. There's no molecules, no air whatsoever. So there are places where there is no friction, but on this planet, we can't ever get rid of it, which means there's always an unbalanced outside force making us slow down. I always like to have students rub their hands together. Rub your hands together, do it for a long time. What do you feel after a while? So after a while, you feel hopefully that your hands are warm. You can, if you have a temperature sensor, you can put a temperature sensor up there and you can prove that to yourself that that your hands heated up. This happens a lot. Happens in brakes as well with cars. When you hit the brakes on your car, your brakes heat up a lot. And the point of this is to show you that the way friction opposes motion is by converting kinetic energy, which we'll talk about later, but kinetic energy is the energy of movement. So it's converting this energy of movement in my hands to heat energy. It's taking away energy of movement and converting it into heat. So that is the mechanism whereby friction opposes motion. That's how friction opposes motion, is it converts kinetic energy to heat energy. There's some well-known examples of that. When space capsules come back to Earth from outside the Earth's atmosphere, when they come back in, they're reintroduced to air molecules, which impart friction. And they're going at a very high rate of speed at that point, up to 17,000 miles an hour. The friction is so much, it creates so much heat on the way down that literally these things can get red hot. There's a lot of burning off of some surfaces of that air capsule. And as they splash down, this is SpaceX from this past year, you actually see some burned marks on that space capsule because of the friction from the Earth's atmosphere. In addition to that, move this out of the way. You might have seen something like this before. And many people see this in the sky and they say, oh, look, it's a shooting star. Well, no, it's not a shooting star. It's not a star at all. There's absolutely no way that a star can move that fast across our nighttime sky because they're so far away. What it actually is a meteor. It's a meteor entering Earth's atmosphere in much the same way as this space capsule did. But this is just a rock. There's lots of rocks that are flying through space. They enter Earth's atmosphere, and because of the high friction, they literally burn up in the atmosphere. There's lots of meteors that enter our atmosphere. And because of Earth friction, thanks to Earth friction, a very, very small percentage of them actually end up hitting the Earth's surface. Most of the time, by the time they get to the Earth's surface, they've all burned away and disintegrated because of the force of friction. So there are two things that determine the force of friction that acts on an object. Hopefully these two things make sense to you, but the first one is the types of surfaces in contact, because the fact of the matter is not all surfaces provide equal amounts of friction, right? So we have things that have low friction, like wood, like plastic. If you're on a wood floor, you've probably done this before where you slide in your socks on a wood floor or a plastic floor. As far as plastic is concerned, lots and lots of slides are made of plastic because it's a low friction material. It's easy to slide on that thing. as opposed to these high friction materials like rubber, concrete, sandpaper. These things are well known to have lots of friction. I'm sure you already know this. We use sandpaper because there's lots of friction. It smooths away wooden surfaces, helps us to smooth that out. We use rubber for tires. We drive on concrete and asphalt. These things are well known to provide high amounts of friction. So different types of surfaces provide different amounts of friction. You need to know that the coefficient of friction is a special physics concept. It's a constant that is a number that indicates that amount of friction. It's indicator of the amount of friction that a material can provide. And specifically, the higher the coefficient of friction, the more friction it provides. For instance, the coefficient of friction for plastic is somewhere around 0.3 to 0.4. That's a fairly low coefficient of friction. Coefficients of friction usually range from 0 to 1. Most of them are decimals, and it's actually unitless. It does not have units. So the coefficient of friction for plastic is 0.3 to 0.4, whereas the coefficient of friction for rubber, very, very high friction, somewhere between 0.8 to 1, and sometimes even higher than 1. So high amounts of friction for rubber. So the coefficient of friction, the point of this slide is to show you that the coefficient of friction is a number that indicates that amount of friction. But on any surface, regardless of what surfaces are in contact, we use lubricants to reduce friction. And the way that works is that it decreases the amount of surface contact. And so we use things like oil, grease, even water can be a lubricant. And that works, again, by decreasing the surface contact. So here we have two surfaces that are in contact. And let's imagine that there's no lubricant in use here. When these two surfaces move back and forth, they're directly in contact with each other. And that increases the amount of friction because there's more surface in contact. That could be a good thing or a bad thing depending on what scenario we're talking about. But now if we have the same two surfaces and we insert a lubricant in between them, oil, grease, water, something like that, now what it does is it can allow these things to move back and forth more freely because they are not quite as in contact as they were before. So that's what lubricants do. Several examples of this. If you've ever watched NASCAR, you might have noticed that they use tires that look like this. These are called racing slicks. They are slicks because they are slick. There is no tread on these tires. And for that reason, they do not run any NASCAR races in the rain. They use racing slicks because turns out if the surface is dry, the more surface area you have in contact with the road, the better force of friction you get, right? And so that's really important for a NASCAR race because those guys are going really, really fast, like 250 miles an hour. They need lots of friction on the road to keep them safe. Our tires don't look like this. They have tread on them. You don't have tread to increase the amount of friction on the road per se. If we want to increase friction on a road, we would use slicks. I would put as much of the surface area in contact as possible. No, the reason we have slicks and the reason why NASCAR racers can't race in the rain is because of the water. So in the water, a NASCAR racing slick really just acts like a big floaty and it reduces the contact on the surface, and those guys are going to slide around all over the place. The job of tread on your tires is it allows you to drive on a wet road. There's an illustration here of a tire on a road. What the tread does is it actually provides little channels for the water to go into preferentially, so that the surface of the tire can actually remain in contact with the road. So what that basically does is it allows the two surfaces to remain in contact. But even in that case, if there's too much water on the road, that's not going to work either. In this case, on roads, water can act as a lubricant for the road. Another example of a lubricant, ice skating. If you've ever ice skated before, what you're actually doing is ice skating on a layer of water. So if I blow this picture up, when you skate on the ice, what happens is momentarily the surface of the ice skate on the surface of the ice, it actually melts the ice just a little bit so that you're actually skating on a layer of water. And that layer of water kind of acts as a lubricant. It separates the surface of the ice skate from the surface of the ice. And this right here is the reason why there's very, very low friction on ice. Your engine oil is another example. So we put oil in an engine. Your engine in your car requires oil, and it requires oil changes all the time because that oil is always being used and it gets dirty. There's lots of engine surfaces that are rubbing against each other. Most importantly, the surface of the piston and the outside of that piston chamber. These surfaces rub against each other, and it's this friction, it's this rubbing that causes the engine to get very hot. It can get so hot, as a matter of fact, that if you don't have oil and you don't have other things to decrease the temperature of the engine, the whole engine by itself can melt together and just become one giant block of steel. So we need engine oil to reduce the friction and keep the temperature of the engine relatively low. So that's the first thing that determines the force of friction, the types of surfaces in contact, which again is related to that coefficient of friction number.